All right, let's take a look at number 5. Carousel moves in a counterclockwise direction. It makes one complete revolution every 20 seconds. Han is sitting 10 feet from the center of the carousel. Here is a view of the carousel from above. Okay, so here is the center. Okay, and Han, it looks like, is sitting directly down from center. Based on the view from above, write an equation describing Han's vertical position in feet relative to the center of the carousel t seconds after the carousel starts moving. So we've done some problems similar to this before. We know that whether it's a windmill, whether it's a carousel, a Ferris wheel, we know this is going to be a sine graph. So first of all, we know this is going to be a sine graph. So this is going to be some sort of sine graph, and they want us to use the variable t. So we're going to use the variable t instead of x in this case. And then we're going to fill in all the appropriate spots. So let's start with this number right here. So this number, the number that goes directly in front of, in this case, sine, is the a value, which is the amplitude. And we know that the amplitude of the sine graph represents the length of the windmill blade, or in this case, the radius of the carousel. So we are told, based on the picture, that the radius of the carousel is 10, which means our amplitude is 10. So that means the number that's going in front of sine is going to be a 10 here. Okay, so we've used that one so far. Okay, the next thing we're going to look at, the next thing we're going to decide on is this one right here, this number right here, which is the b value. So the b value, remember, helps us find the period. So that number that goes in front of the x, or in this case t, inside the parentheses is the b value, and that's used to find the period. So the period, the formula for period, remember, and I'm going to do this down here, is 2 pi divided by b. Now, we, of course, know we are told that it makes one complete revolution every 20 seconds. So that means that the period is 20. So I'm going to set 2 pi over b equal to 20. Okay? And by doing that, I can figure out the b value, and thus the number that goes in front of the t here. So if I cross multiply, okay, if I cross multiply, I'll end up with 20 times b. So 20 times b equals 2 pi times 1. Okay, and I'm going to divide both sides by 20. Okay, and I end up with b equals 2 pi over 20. Okay. Now, you have a choice here. We could reduce this, or we could leave it as is. I'm just going to leave it as is. Okay. So that would mean the number that goes in front of the t inside the parentheses would be 2 pi over 20. If you wanted to, you could reduce this. 2 pi over 20 could reduce to 1 pi over 10, since these are both divisible by 2. So you could put 2 pi over 20 or pi over 10 in front of the t. Either one I would accept as a correct answer. I'm just going to leave it as 2 pi over 20 in this case. All right, so we've used the period. Okay, the next thing we're going to look at is the fact that Han is directly down from center. Okay, normally we have looked at examples where the carousel or the windmill is starting at the 0 degree or the 0 radian mark. In this case, Han is not at the 0 degree or 0 radian mark. He's at the low point of the circle. So he's starting at a different angle measurement other than 0 radians. So we know with windmills and with anything circular, the angle position where the windmill starts, or in this case, the carousel starts at, represents the C value and the horizontal shift. So the C value is the plus or minus that is inside the parentheses after X or T. Okay. So that's going to be the number that goes here after the T. Okay. So he is starting at the low point. So the question is, what angle measurement represents the low point of a circle? We learned in the first half of this unit that this low point is either 270 degrees or 3 pi over 2 radians. So that means the C value is going to be positive 3 pi over 2. So this is going to be positive 3 pi over 2. Okay, so that horizontal shift, or that C value, is going to be positive 3 pi over 2 because that is the angle measurement where Han is starting at. Okay, and looks like we've used all the numbers. We've used the fact that it makes a revolution every 20 seconds. We've used the fact that he's sitting 10 feet from center. Okay, and we've used the fact that he's starting at the 3 pi over 2 angle mark. So this right here is my equation. If I put it all together, I get an equation of 10 times the sine of 2 pi over 20t plus 3 pi over 2. So 10 times sine of 2 pi over 20 times t plus 3 pi over 2. That is your equation, and that is your answer to number 5.